Alright guys, here with PS3 model CECH E01, and this is just going to be a quick little voltage check on the rails, because a lot of people, when they start having PS3 problems with the older models, like I have here, including the A01, a lot of times it's the power supply, and well, quick voltage check can either tell you, well, it is the power supply or it's not. So there's some tutorials. They have you have the board out of the chassis, and you have the probes into the main 12-volt output that's on the back side here, and you hit the switch on and you power it on with the reset button, and you're supposed to see that 12-volt voltage spike. Well, you could do that, or you could just remove the cover like I have here, and this leaves you access to all of the rails. So for all of you electrical engineering gurus out there, this is just an Amprobe AM270 meter. So we're just going to go ahead and check the voltages. I'm going to put it's going to be with respect to ground. So I'm going to put the probe on the ground there. What we're looking for is your CMOS voltage for 3.3 volts DC, your logic voltage, and like your small motor voltage, and here might be 5 volts. Then there's also your 12-volt rail, which also goes to the Blu-ray disc player. So we'll go ahead and check that from this white cable back here. So we're reading 3.174 volts. Plus or minus 5% from 3.3 is within specification. That's generally how it is with ATX power supplies. I didn't do too much of a search for this one to see what the exact rating was percentage wise, but usually it's plus or minus 5%. So, and yes, it is working properly. The screen is displaying on the XMB home menu. Go over to the next one, ground. The next one over, also ground. Then the next two should be 5 volts. We're getting 4.977 volts within spec, and 4.977 volts within spec. Now we'll check the Blu-ray power output, which is this other cable connector here. 5.108 volts, good. And 12.06 volts. And the other two are ground. It should be. Yep. So that's that. And this power supply is from the CECH E01 model. It's a little bit different from the A01 model, which that's this power supply here. I forgot the exact model number of this one, but this is APS 226 for the A01 model. It seems to be a little bit more beefy power supply. I've taken the tops off of them. This one has a little bit more filter caps in it. I think it's a little bit heavier. I haven't thrown it on a scale, but it seems a little bit more beefier. Temperature-wise, they both operate hot. In fact, we'll go ahead and connect the temperature probe. If you want to get stable output readings for your voltages, by the way, you generally want to have your electronics warm up for 20 or more minutes. And when working with like oscilloscopes or semiconductor analyzers, parameter analyzers, you want to have the equipment warm up for about 30 minutes or so, just so everything stabilizes. Similar thing here. So this is pretty hot. I can't hold the back of my fingers on that without burning myself. This is a temperature probe. I'm just going to Stick it on there. And it's stable at 58 centigrade. Guess we can move it around. Maybe in here. 54 centigrade. So yeah, it runs pretty warm. But for all the PC overclockers out there and guys who are familiar with operating temperatures, that's perfectly normal. Usually the extreme gets to about 90 C or so, but I know I like to keep my computer running below 60 C. I air-cooled my system. It's over there, but we won't go into that. I'll go ahead and shut this down. And we could read the voltages on one of these A01 models. I want to figure out what this one's been sitting around in my room for a while. I have PS3 parts all over, so I like to leave the power cord plugged in, not only on my PS3 but even with my computer if I'm cleaning it or changing components. I'll leave it plugged in so it's connected to mains ground, but I'll make sure the mains input is switched off so there's no power. I just do that for ESD protection. I don't want to blow any components. You gotta be careful. Also try not to burn myself because this bad boy's pretty hot. Yeah, that's hot. Alright, yep, this is the APS 226, and for anyone wondering, that's hot. Okay. The model of this power supply was ZSSR5391A. But anyways, let's plug this in. This is cold, so what? We're not going to sit here for 20 minutes and let it warm up. And a lot of today's electrical equipment also has calibration features that auto-calibrate. So, in essence, they're pretty much turn on and go devices. But either way, I still like to have my equipment warm up for that 20 to 30 minute interval. Some equipment I've used actually gives you an error message, unable to take measurement because it needs that warm up period. Go ahead and power it on. I connected everything. Switch it on. So the previous supply we tested, it was stable down to, let me see what digit, I think it was the third decimal place. Yeah, the third decimal place. It was stable too, and it wasn't switching back and forth. I just turned this on. It's a cold power supply. I'm going to take the voltage reading at the 3.3 volt CMOS rail. It's 3.291. It just jumped from 3.290. Can we get any change? Usually you get fluctuations because it's warming up. Maybe the 5 volt rail will show it. 5.30, 5.301, and jumped up to 5.032. Anyways, also in spec, 3.291 for the 3.3 volt rail, 5.032, 5.027, 5.030. We're good. Blu-ray voltage rail, 12.06 volts. And again, you can check the 12 volt rail just by checking that voltage instead of pulling the board out, getting your probes in there and tinkering with turning it on and waiting for that voltage spike. I don't care if you're taking it apart. Try to do as less work as possible when you're doing electrical testing and all that. And the other rail is 5.108, so we're good. I think though I'm going to reassemble this and leave the it's getting warm already, and leave this APS 226 power supply in it rather than this newer model, but it's still hot. Oof. But anyway, that's that.